Hello. Glad to be here to talk to you about the digitalization of factories. We've been talking about digitalization of lots of industries today, and we've been talking about Internet of Things and getting the data up to predicts and being able to do wonderful things with it. But I'm putting robots in factories, the 90% of factories that have never had robots in them. And in those same factories, Internet of Things is going to be very important. But they're very different from a lot of the domains we've seen today where a top-down approach works. I go into factories all over the world, and I find factories where they've standardized on what operating system they're going to use on all their PCs. They're using Windows 97, and a lot of the applications are running in MS-DOS emulation. It's a very brownfield sort of domain with 40 and 50-year-old equipment running together. How do we get to a digitalized world? And so I think that one of the ways is, as we put robots into these factories, the robots become the center of the digitalization, and we do a very bottom-up approach to getting the Internet of Things, rather than a top-down approach, which is what we've been seeing a lot of today. So let me just tell you one thing give you an example of what's in existing factories. Programmable logic controllers, and I've seen a couple of people mention them today. Programmable logic controllers were a great idea when they were invented in 1968. They replaced racks of relays, you know, electromagnetic coils that pull switches down physically, and they emulate those. The first programming language for them was graphically copying circuits for relays in a way that you couldn't screw up. And there's a lot of different programming techniques for them today, but they're still based on the abstraction of electromagnetic relays. And the networks that connect them together are based on that same abstraction. And when you have automation in factories, you often have big racks of lots and lots of wiring that wires together these emulated electromagnetic relays through, and then networks called Modbus, which inside it thinks it's electromagnetic relays. And it's so hard to change these things that people often change their process rather than change their automation when they have a new product. So into those sorts of areas, I'm putting robots, collaborative robots, which are a new sort of industrial robot. They're safe to be close to. Here's one of our robots and one of our engineers, Shiwei Wang, and she's got the hold of the end of the robot, and it's sensing every force that's applied to it and trying to give zero force onto her fingers. So she's able to move it around even though it's a large machine. By the way, the arm is longer than hers because we're trying to put these robots in places where people work, but people have hips. The robot doesn't have hips, so we need a longer arm. So we put these robots, here's some earlier models, in factories close to people because they can sense forces. They're safe. If you look at the left picture there, just to the right of the left, on the right side of the left picture, you'll see a guy with his back to the robot. Don't do that with an existing industrial robot. Don't turn your back on them. Not because they're out to get you, because they don't know you're there. They'll just whack through you, and it's not going to be pleasant. But these sorts of robots that we've been building, they sense with various sorts of sensors, and if they do hit you, because they're measuring forces, the very small forces, they're able to stop, and it's safe to interact with them. But more than that, we've taken something out of the playbook of smartphones. Instead of programming these robots, instead of having symbolic code, we make it so that an ordinary technician, an ordinary factory worker who hasn't been trained at all can learn how to use them. When you got your smartphone, you didn't have to go to community college and take a course on how to use it. The smartphone trained you how to use the smartphone. We make our robots train the users how to use the robot. And so the technician or the factory worker will show the robot what they want done. They grab hold of the end of the robot, they move it around. It's not recording their motions, it's using AI and little rules, like we just saw in the previous talk, to understand what the person is trying to show it. So if the person takes a robot hand and closes the fingers, the robot, in a little rule, says, there was nothing in my hand, then I closed my fingers, then there was something in my hand. This must mean the person wants me to do a pickup operation. But it's that task level pick-up operation, not the particular coordinates. And then the person might say to it, by showing it, that there's a little marker, a little fiducial marker, and say pick up relative to this fiducial marker. So if the tray that it's getting pieces off of with the fiducial marker on it moves around, the robot knows how to move around by using vision to see where that is. So the technician trains the robot, and then the robots are able to work in factories where people are close by. This happens to be a factory in Changsha in Hunan province in China. China has a terrible labor shortage now as the demographics changes there, 30% drop in 19-year-olds, but they've got a great supply chain for electronics, so lots of small factories are trying to get robots in, and they train the robots to do these simple sorts of operations. They build fixtures, by the way, with 3D printers. We see 3D printers in factories all over the world, hobby 3D printers for making fixtures. And then the robots use vision to localize where these parts are. They use force sensing as they do insertions, and they're able to do assembly operations. The eyes on the screen, when it's not being trained, look where the robot is about to reach, so the workers are not surprised by the robot moving, because just like you always glance before you reach somewhere. The robot does the same, metaphorically, with that screen. That screen becomes the programming or the training interface when you're showing it what the task is and has menus on it. So now we put those robots out in factories, and in the US, our smallest customer is a company that only has 9 employees, does manufacturing. Our biggest customers have hundreds of thousands of employees. But a lot of places we go, there's old equipment there. And so we're now replacing the PLCs that I talked about before by the logic in the robot. So instead, when you want to change your automation equipment and what it does, you use the same train by demonstration, showing the robot, showing the equipment what it wants to do, and now you've got a way of flexibly having software control all your existing automation equipment. Now, at the same time, as the robot is operating, here it's putting a DIMM into a motherboard, you can see that it's measuring forces, and this was trained on how to do this task. So it's putting the corner in first, as a person would, feeling it, pushing it in, and now it's got to do a push-down lock operation, and it fails. The force that it feels is not what it should be feeling, so there's a little data there that's being generated. Here's a successful one. And this is the sort of thing that you'd like to feed up to Predix. You'd like to have all this information from manufacturing go into the cloud so that you could do all the wonderful things we've seen today and yesterday with Predix and Predix-like systems. Here's another example. This is inspecting an automobile engine. It's pulling on this cable to make sure that it's actually locked in there. It's going to do it twice where it was, and now we'll have an example where it wasn't seated properly, and the robot is able to tell that it wasn't seated. So you get data, you inspect, but you do get data which you'd like to analyze further. We think that's what the customers should want. The customers, however, are really just, okay, is this robot making me more productive? That's all I can think about today. But over time, because we're giving them value of not having to have these horrible PLCs that are hard to change and hard to reprogram, they become accepting of having technology that connects to their existing automation, and then we can say, oh, by the way, there's this other thing called Internet of Things that you didn't want to hear about because it sounded too complicated. You didn't want to know about it, but you got it for free. And all that we need to do is have little smart modules, really smart modules out of smartphones, attached to existing industrial equipment, have the robot be the center of the universe, and these very small companies or very innovation fearful companies get the benefits of IoT and the cloud. And so we go from just a single robot doing things to a work cell to the whole factory doing things. And that's what the vast majority of manufacturing around the world is like. It's not the big clean sorts of systems that we imagine when we think about a GE factory making airplane turbines or locomotives. It's a much messier world out there. But IoT is getting there. So thanks for your attention.